Hi friends, here in this video I'll be explaining the analysis of Potter governor. So let's get started. Now here is a diagram of a Potter governor. Potter governor is basically also called as a deadweight governor. In this governor what happens is, first of all, here there is a center line. At the center line which I am showing here, there is a spindle or a shaft which is continuously rotating with angular velocity. I am assuming it to be omega. So the spindle is rotating, and on this spindle here we have a dead weight which is kept, and this portion is called as a sleeve. At the same time, these are the upper links of the governor, and here we have the lower links which are connected to this part which is called as a sleeve. Then at the sleeve we can see there is a heavy mass which is kept. The CG of the mass is denoted by capital G, and through it the weight capital M into G is acting for this dead weight, because Potter governors are dead weight governors in which we are keeping a heavy mass at the sleeve or at the center. Then apart from that we have these circular fly balls. Fly balls are having mass small m, so the weight which is acting from the fly ball is small m into G. Similarly onto the other side, small m into G. Then when the spindle is rotating at a very fast speed, in that case here we are having the radius of rotation from the center up to the fly ball center, that is from the spindle center to the fly ball center. R is the radius of rotation, and we are going to get different radius of rotation or different radii of rotation for different kinds of speeds. Now at the same time, since this spindle would be rotating with a very high speed, and if it is rotating with a high speed, then what happens? There would be a centrifugal force which would be acting away from the center. The centrifugal force will try to move away from the spindle, and that centrifugal force is generated by these fly balls. We can see the centrifugal force is mr omega square. So the heavier the mass of the fly balls, the greater would be the centrifugal force. The more the radius of rotation, the greater would be the centrifugal force, and the more the angular velocity of rotation of the spindle, more would be the centrifugal force. So the principle of working of this Potter governor is such that when the speed of the spindle increases, the fly balls would be moving away, radius of rotation increases, and that happens, that is the speed increases when there is less load or no load on the engine. And if the load on the engine increases, at that time the speed decreases, so the fly balls would be moving inside, and when the fly ball move inside, the radius of rotation decreases and we get decrease in speed. So the movement of these fly balls would be moving this sleeve, and this sleeve would be connected to the fuel supply directly, and we are going to directly control the fuel supply, and by controlling the supply of fuel to the engine, we can control the speed of the engine. So governors are used to maintain a constant speed, and that constant speed would be maintained by changing the fuel supply, and that fuel supply would be changed because of the movement of the sleeve, which is in turn dependent on the movement of the fly balls, and which is dependent upon the rotation of the spindle. Now I'll quickly explain the forces which are acting over here. First of all, on the upper links, when the fly ball is moving away, a tensile force, or we can say the tension T1 is acting. At the same time, the link is resisting the tensile force. So here we have two forces over here which are indicating the tension in the upper link. Similarly, the tension in the lower link denoted by T2. Next, the angle made by the upper link with the center or the spindle is alpha. Similarly, when I extend this link, when I extend it with the help of light line, and when I draw a light vertical line which is indicating the weight of the fly ball, then here also we get angle alpha. These are called as corresponding angles. Next, similarly, the angle made by the lower link with the vertical is called as beta, and therefore the angle made by the lower link from the weight of the fly ball is also beta, and that is due to alternate angles. Next, this capital Mg gets divided equally along the center line on both the halves, that is along the left and right side. So capital Mg is the weight of the dead weight which is kept over here, also called as the weight of the sleeve. So it is divided capital Mg by 2 on both the sides. Then here there is an instantaneous center denoted by I, about which the links would be rotating or links would be moving about this common center capital I. Then A is the center of this fly ball, and when I extend this line, here we get the intersection at the horizontal called as AD, and next here B is this point where the lower link is connected. So the number of forces which are acting are the weight of the fly ball, then the weight of the dead weight along with the sleeve, then we have the centrifugal force. So for the analysis purpose, what we have to do, if I am considering the overall governor and if I take all the forces, so the governor is completely balanced, that is it is in the equilibrium condition. But for analysis, take only the half of the governor, that is from the center line, take only either the left portion or the right portion. Here I am taking this left portion for the analysis purpose. So when I see the number of forces here, we have Fc, which is mr omega square, called as the centrifugal force acting away from the center, small m into g, the weight of the fly ball, and capital Mg by 2, that is half of the weight of the dead weight or Porter governor, we can say the dead weight or the sleeve which is kept. So another half is onto the other side, we have to take only half, and then I am going to analyze only this much portion, that is the left half of this governor. So at first, and secondly, what I am trying to explain here is also the height of the governor. And how do we get the height of the governor? For that you all can refer my video in which I had explained the height of governor, whose link would be provided in the description of this video below. So you all can refer that. That is the height of the governor. For time being, I am explaining that at the intersection of the upper links or upper arms, we get a point O. So from this point O up to the center of the fly ball, it is called as the height of the governor, denoted by small h. Now next thing what I am going to do here is I am going to take the moments of all forces about instantaneous center I. So here the condition is summation of moment about point I is equal to 0, clockwise moments treated as positive, anti-clockwise as negative. So when we are looking into this left half, Fc, the centrifugal force, when I take the moment about point I, it is acting in an anti-clockwise manner, so that would be negative. So minus of Fc centrifugal force into, now the height is, I can say it is up from A to D, that is Fc is the horizontal force and moment is nothing but the multiplication or the product of force and the perpendicular distance. So force is Fc horizontal, perpendicular distance is AD, so it is minus Fc into AD, minus because acting in an anti-clockwise manner. Then we have small m into g, which is the weight of the fly ball, and when I take the moment about point I, it would be in a clockwise sense, so positive small mg into id. Then here we have capital Mg by 2, which is acting in a downward direction. When I take the moment about point I, it is also coming in a clockwise direction, so plus Mg by 2 into the total distances from I to B, IB, is equal to 0 because we have these three forces. Then if I send Fc into AD, which is negative, onto the other side, it would become positive. So onto the equal to sign, on one side we would be having this term and on the other side we have Fc into AD. So therefore I'll write down Fc into AD is equal to weight of the fly ball id plus half of weight of the sleeve or the dead weight which is kept. So we reach up till here. Now therefore the centrifugal force, we know it is mr omega square. Next, distance AD. For that, what I can do is dividing throughout by AD. So when we divide it throughout by AD, this AD gets cancelled and what we have here is mg into id upon AD plus mg by 2 ib upon AD. So basically what I have done here is divided throughout by AD. So we reach up till here. Then for id upon AD, ID we are having in this triangle, and here we have AD. So I'll just separate the triangle and explain. Here we have point A, this is D, and here we have I, and here there is an angle alpha. So I need ID upon AD. From this triangle I can say ID upon AD. When I look into it, ID is the opposite side to alpha and AD is the adjacent side of alpha, whereas AI is the hypotenuse. So ID upon AD, that is opposite upon adjacent, gives us tan, so which is tan alpha. So basically ID upon AD would be replaced by tan alpha. Next, IB. I can also say that IB is made up of ID plus DB. They are having a common denominator, which is AD. So again, ID upon AD is tan alpha plus DB upon AD. For that, I have to take this triangle, which is ADB. I'll explain by separating it. This angle is beta. Now what I need here is DB upon AD. So therefore DB upon AD is equal to, now when I look at this angle beta, DB is the opposite side to it and AD is the adjacent side. So opposite by adjacent is tan, that is tan of beta. So DB by AD would be replaced by tan beta. Next, after this, here I would be finding, that is I am keeping mr omega square as it is. So here in this analysis I would be finding the height of the governor, or at the same time I can say omega as well. So for that, what I'm doing right now is I'll keep omega square on one side, bring m into r onto the other side. So for that, keeping omega square on one side, here I have mg tan alpha divided by m into r plus mg by 2 m into r tan alpha plus tan beta. So therefore, when we look here, we can say that small m gets cancelled from here, and here we have tan alpha. Tan alpha can also be substituted, like for example, I'll just show it over here with the help of the diagram, that I need to get the height of the governor. So now when I take this triangle, which is OGA, from triangle OGA also I can get tan alpha. Now this tan alpha would be opposite side, which is R, and adjacent side, which is H. So in triangle OGA, tan alpha is R upon H. Triangle OGA, this is R, here we have H, and this is alpha. So tan alpha basically is equal to R by H, because I want the height of the governor. So I would be replacing this tan alpha with R. Already we have R in the denominator, so this tan alpha is replaced by R upon H. G upon R were there previously. Then plus, next thing which I can do here is I am keeping mg as it is, 2mr for time being I am keeping it as it is. Here I can take tan alpha common. Inside the bracket we have 1 plus tan beta by tan alpha, because I have taken tan alpha common. Next, after reaching up till here, therefore omega square will be equal to, here R and R would get cancelled. Similarly, this tan alpha. So here I have G by H which remains plus mg by 2 mr. Tan alpha previously I had replaced it with r by h. So again I am writing it as r by h. 1 plus the ratio of tan beta by tan alpha is replaced by q. So I can write down, since q is equal to the ratio of tan beta by tan alpha. So here as well I can see r and r getting cancelled out. So G by H can be taken common. Here we have 1 plus capital M upon 2m, and G by H has been taken common. So here I have 1 plus Q. Then here what I'll do here is keep H on one side, bring omega square on the other side. So therefore bringing H on the other side, here we have G upon omega square 1 plus capital M divided by 2m into 1 plus Q. Now omega we know it is, since omega is equal to 2 pi n upon 60. So when I place the value of omega, keeping h on one side, so therefore h is on one side. In the numerator we have g. I'll put the value, that is 9.81 meter per second square. So g is 9.81. In the denominator we have 2 pi n upon 60, which is omega, and here we have omega square. So we have to make the square of this term. Now the constant over here. So now keeping h on one side, 9.81 divided by 2 pi upon 60 the whole square will give me the value as, it comes out to be 894.56 divided by n square, which remains here. Now therefore this h, here this value can be round off and it can be made equal to, it is very close to 895. So the final form would be 895 upon n square. So as we see here, we can get the height of the governor by using this formula. Basically this formula gives us the relation between the height of governor and the speed, or we can say the RPM of rotation of the spindle. So if we want the height of the governor, we can find out if we know the speed at that position, and if we know the height we can find the speed. And at the same time in this formula, if suppose q value is equal to 1, now when will q be 1? So we can say that since q is equal to tan beta upon tan alpha, and if it is equal to 1, just for an example, so it is equal to 1, it means alpha is equal to beta, and when alpha is equal to beta, we can say that the inclination of the upper links and the lower links are same. That is, if the upper links and lower links are having the same angle. And how is it possible if they have the same angle? Because when the height is same, at the same time the radius of rotation is same, so and even the link lengths are same, so alpha would be equal to beta. And if alpha is equal to beta, we can say q, the ratio is equal to 1, and if q is equal to 1, this becomes 1 plus 1, which is 2. So 2 and 2 will cancel out, and finally the formula would remain 1 plus capital M by small m, because 2 and 2 will get cancelled out. So this formula should be used if the link lengths are equal and even the radius of rotation is equal. So we can get the same value of angle. That is, it is used for this condition where q value is equal to 1, and by using this formula we can find the height of the governor. Speed should be known. At the same time, capital M is the mass of the dead weight, and or we can say the sleeve, and small m is the mass of the flywheel. So in short, that was an analysis of the Potter governor. At the end, if you all find my videos helpful, you all can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.